Okay, Year 10, welcome to your video tutorial on two-way tables. Today we are going to again look at the probability of overlapping events, but this time we're going to look at a different way to represent them, not Venn diagrams, but two-way tables. Like Venn diagrams, two-way tables are a useful tool for the organisation of events that overlap. So I know last lesson I was going around trying to demonstrate this idea to you guys a lot, and we had a look at gaming. Now, there's whole lots of different types of games. You don't have to just like one. And when I did a survey, lots of people were putting their names down in both categories, okay? So, like the Venn diagrams, the two-way tables use columns and rows to describe the number of events in overlapping regions. So rather than doing circles, they do it in columns and rows. So, the Venn diagram on the right-hand side here shows the distribution of elements, okay, in two sets, A and B. So instead of RPG games and, FPS games, instead of people who like Game of Thrones versus Breaking Bad, I've just tried to demonstrate it with letters. So A and B, okay? So 2 people picked A, 6 people picked B, 1 person picked A and B, and 3 people didn't pick either of them, okay? And that was the results. And we've been asked to please demonstrate this in a two-way table. Okay, so how many people picked A and B? So this first one here is for people who picked B and A. Okay, so that's how I've drawn up my table. This column here is for not A but B. This one here is for not B and A, and this one here is for neither, okay? So that's how we draw up a table. Let's see if we can get some answers in there. How many people selected B and A? Well, that's the middle one there, so that's 1. How many people selected B but not A? B but not A is 6, okay? How many people selected not B but A? So not B but A, that's 2. And how many people selected not A and not B? Well, that's 3. Okay, these squares on the outside are for totals, so total people selecting A is 3, because remember the guy in the middle selects him as well. The total selecting not A is 9. The total selecting not B is 5, and the total selecting B is 7. That all marries up because 6 plus 1, yep. 2 plus 1, yep. And then the other ones all marry up, which means that there is a total of 9, 10, 11, 12. Yep, and make sure the other way fits at 7, 8, 9, 10, 11, 12. Cool. Okay, so that's how I do my two-way table. This is the overall total. Okay, these are the totals of the columns. These are the totals of the rows. Cool. So I've copied that there, and it says find the number of elements for each of these regions. Okay, how many elements is there for A and B? Okay, in both A and B. So someone who likes both A and B, that is this first column here, so that is 1. Okay, B only, so just B. B but not A. That's that one there, so 6. A only, so A but not B. That's 2. Neither A or B. Well, that's this one here, that's 3. A. Okay, remember, don't just go for A but not B, but it's the total in A. Okay, so that one person in the middle will count as well. So the total for A can be found at the bottom, and it's 3. Not B, the total for not B can be found on this side. It's 5. Okay, so 3 people liked neither of them, so those 3 people count, and 2 people didn't like, 2 people chose not B but A, so those 2 people count, so it's the ones at the ends. A or B, okay? Okay, so the people that like A or B, that's them, they count. This one, because there's an or, they liked A, so they count. These people who like B, because it's B but not A, they still count. Not those people. Okay, so it's these 3 groups. It's 1 plus 2 plus 6, which equals 9. Okay, so the last one's 9. Last but not least, we're asked to find the probability of certain things. Okay, so the probability of finding someone who likes A and B, not or this time, but A and B, is the probability of A and B equals Well, A and B is this guy here, so 1 on 12. The probability of not A, so the probability of not A equals, okay, so people who do not like A is this one down the bottom here, my total, 9 out of 12. Remember seeing if I can simplify. A simpler way to write 9 over 12 is 3 over 4. And last but not least, the probability of finding A only, just A by itself, is going to be, okay, A, that's A and B, this is A and not B, that's A just by itself, so it's the probability of A only equals 2 over 12 or 1 over 6. And that's it, guys, that's two-way tables.